math physics video. Humble pie-ish, maybe? Yeah. Alright, so, yes, the outside observer problem, which I thought was a problem, apparently isn't a problem because you can add more time. And so that changes the equation. So anyway, alright, so this is where we were. That, you know, the photon, if you aim it, if you angle it up, it would appear that it would run short. That this distance would be the same as this distance, and you can't go the longer distance in the same amount of time, and you come up short. But if you go 2 time intervals, nothing changes in terms of this distance. Okay, so that's the catch, because the light would bounce back. There's no, this distance doesn't grow with another time interval. This distance does. You know, the length of this line. And so this distance goes twice as big. So if you did that, you'd see that 2 speed of light seconds would end up, so say this was a 2 seconds, so this is 1 second, you're short. At 2 seconds, you're overshot. So logically, you could say that there's a point where if you lower this, technically, in terms of time, you reduce the time, these 2 dots would merge somewhere here. And at that point would be the only point you can get through the hole shooting the laser at an angle. So that's the only angle it'll go through the hole at, right there. In this case. So the faster you're going, the higher this slope would be. Obviously, this angle gets sharper and sharper. I guess I would still argue that there's a point, if you go like 90% or something, there's some point where it's going to get problematic, but it really doesn't matter. I mean, I suppose it'll be the opposite, because you're always going to have this same line. So no matter how much I slope this, you could always compare 1 second to 10 seconds, or 1 second to 100 seconds. And you always have 1 dot on one side and 1 dot on the other side, and you always have a point where they'll converge. So there's always going to be a point, no matter how many seconds you take, where you could draw that line and it would be, the speed of light would work and the distance would work. So yes, it's disappointing that it comes out that way. You know, in the sense that I thought I had the catch for the outside observer. So now the outside observer does see something preposterous. I'm just saying. He sees essentially the light clock get broken, because the more this line gets moved up, the longer it does actually take for 1 second. Say if the clock was bouncing at 1 second by this distance, obviously it won't be doing that when you're traveling the longer distance. So you're watching the light clock get broken, essentially. So if you were watching a spaceship going faster and faster, and you could watch what was happening to the light clock, you'd see the line getting longer and longer and longer. And it's not counting seconds correctly. But then for the person inside, because they're speeding everything up, it looks like it's going the right speed. So the two would complement each other in the sense that the outside observer is watching the clock get broken, and the person inside, his clock's getting broken at exactly the same speed as the light clock's getting broken. Alright, so I'm still going to contend that in reality, the light doesn't go forward. That you can shoot light. Light can be released perpendicularly, and if you do release it perpendicularly, it will just fall behind, in the sense that it will, the hole will move, the light will hit exactly perpendicularly, the hole will go up here, and the light won't go through the hole. So I still contend that's reality. But I can't make the argument from an outside observer saying that what they're saying happens has a fundamental flaw in it, in the sense that no, if you do aim it exactly right, there will be a point where you can get the light to hit this exact spot. And theoretically, because of the angle thing, you get to hit this exact spot and then hit this exact spot. But I'm still going to argue that there's no reason you can't detect the fact that that angle is wrong. Clearly the outside observer is going to see it as wrong. He's going to certainly see this as not being perpendicular. So he's certainly going to see that that's a flaw in the clock. Something's amiss, so to speak. Yeah. So I have to come up with some other argument, because all this is that the outside observer will see the clock being broken. So I have to come up with an example where the clock is maintained as a clock that accurately tells time and can be moved without breaking its function. But again, that's the whole point is that the movement will break its function. So I guess that's hard to prove the negative, and so I'm attempting to prove that you can't maintain a light clock, and they're maintaining it through this extraordinary yes, light always moves with the thing moving. So if the thing's moving, somehow the light will be forced to move with it. So again, it's still the same momentum argument, in the sense that the momentum is being changed in terms of its direction. So like I said, they added more bus, so to speak. So I was wrong also in my bus analogy. I should have thought that one through a little better. That I was thinking of a real world bus where you got the whole problem with gravity and atmospheric friction, and that you have to throw the baseball harder to get it go forward. But I should have thought of it in a space vacuum. You can just, you could have the baseball in your hand, and you could just barely nudge it in this direction, and it could take 2 years to drift forward and to the window, so to speak. And so there's no limitation on how slowly you move it this way, and that's all this is doing, is just reducing the component in this direction, because it's went the opposite way and is kind of undoing itself in a sense. So yes, you can have a very small increase in the velocity, but there'd still be an increase. So I guess I'm not certain that this mathematics is perfect, that this spot would be exactly the same for the speed of light being consistent and the speed of the ship being consistent. Because I'd still argue there's got to be some difference. But I don't want to do all that math. So I'm just going to cheat with a rough drawing of it for now, and I'll assume they're correct, that the speed of light is maintained because you're traveling a longer distance, because you're taking more time. You're going further in space. Yeah, so I have to 1 point for their side, in the sense that the outside observer doesn't break the laws of physics, he just breaks reason in seeing something that's supposed to be going perpendicular go forward, but it probably works out to be the same. The speed of light is maintained, and it gets to the hole. And so that was the part I was saying you couldn't do. Still doesn't logically make sense. But I'll concede it until I'm prepared to argue it, which I'm not. But again, I will argue that this still isn't reality. I mean, this is a trick. That's all. It's just taking advantage of the fact that your time is only expanding one dimension. So time, by adding 2 seconds, I don't add any distance here. I just add distance here. So it's kind of cheating, kind of. Yeah. And so the thing to come up with is some way to detect the fact that the light's not coming out perpendicularly. And I went through some of that with trying to come up with, putting impediments in the way or something to somehow catch the fact that the light's not coming out straight. You think that would be semi-easy to detect, but it's a lot harder to detect when you start thinking about it. There's always a catch, where you can't detect the fact that the light's coming out the wrong way. But you really should be able to. So I just have to think more on it. So, so the subject's not closed, but and I'm still going to argue this isn't reality, because photons don't do this go the wrong way thing. But whatever. We'll see how it progresses. See if I can find some better argument against the gimmick. It should be defeatable, because in my opinion it's just a gimmick. There's nothing real here. It's like I said Einstein was clever. This is a clever combination of time and distance, where he warped it, warping the two. But it's just a gimmick. So anyway, till next time.